So before they end up in the commit, in the JSON commit.
Double
So
encoding.
Yeah.
So we're doing the whole
transaction logs that have the add action path.
Yeah.
Is double encoded. Okay.
Yeah.
Okay, and where?
That's not great.
Like on every code path. So it's not what you mentioned, right? You fix that at some point so that we encode the partition values and then we encode the whole thing again, right?
Yeah. So the partition value serialization and encoding of that's fully compliant now.
Okay, cool.
But somewhere down the line, we then again encode the whole path before committing it to the JSON.
I mean, just the thing I'm trying to, but did we do this before? Encode the entire path once? Because that's part of the protocol, right? The path needs to be encoded in the protocol and back encoded when you read it, the add actions.
Like you need to encode the whole path again, even though the partitions were already serialized?
Yeah, the partition values are already encoded, but
Yeah.
you need to encode the whole. Well, actually, let's just look at the protocol really quick.
Because if that's the case, then what we're doing is correct, and then that fix is not a duct tape fix, but an actual fix.
Okay, so now we'll go into Infinity really quick. Yes, okay, but now you see the now you see the protocol
Yes.
here, right? Okay, then let's go to. Let's make this a little bit larger. Let's go to action path. So here, I'm not sure, right? I mean, but what this says, which needs to be this path is the URI as specified by this, which needs to be decoded to get the data file path.
But it should already conform to that RFC, given that you have done the partition value serialization correctly.
Well, I mean, the rest of the path might still contain stuff that's not compliant, right? You might have a prefix with like spaces in there or stuff like this that also needs to get encoded at that point. So the only encoding the serialization or the partition values is not enough, I think. Because again, the rest of the URL might still, or the rest of the path might still have something in it, but we do encode things. Let's just see if they.
Well, now I'm reading that RFC that was linked, and the day is taking a turn for the worse.
Which RFC?
About path.
Yeah, good luck.
What I didn't know was that URL is a more specific subset of URI. I thought they were adjacent concepts, but URI is a superset, which is interesting.
It also gets confusing between the versions of the RFC for URI. You have the one that starts with 2.9 and then 3.8, but there are subtle differences between them.
Yeah. I
Well,
mean,
as far as
to
I
be
can tell,
honest,
if that's what those actions are supposed to be, the relative path doesn't seem like that's valid. That's not a URI.
well,
Yeah.
I mean, so far it's worked for us.
Well, yeah, if you say it's a URI, but everybody treats it as a relative path, then yes, everything will work.
Yeah. I mean, recording with the encoding and stuff, I didn't find something where I'm like, okay, here, this is where it says this is what it should be doing.
What it's to be.
However, the fact that it doesn't blow up entirely and people say Spark isn't reading your commits tells me that we must be doing the same thing. Otherwise, they shouldn't be able to read the thing at all, right? If they're like, yeah, no, I'm not decoding this. So yeah,
in that case, then the fix should be saved to merge because it just does another decoding step before you do a lookup.
Okay, yeah, I'll.
But I didn't add a test.
Womp womp.
I was lazy and I wanted to get it fixed quickly.
Yeah, and you're one of the ones that's always asking people for a regression test.
Then I did do my regression test.
Almost every time on a pull request, Ian's like, "Could you add a test, please?"
All right. I'll share the other thing again. I.e. this. Okay, so the exciting thing is, at least for me, we already rebased. Which I didn't expect to be so painless, but
Hooray.
it turned out to be fairly okay. So table provider. So what this PR does, and obviously we're not looking at the PR, but we already have like hidden in DataFusion a new DataFusion engine that we're not using anywhere. This engine can be in principle generalized to be like an arrow engine because this one doesn't really have to depend on DataFusion. Yeah, there was just I had some issue implementing the different traits for one another. So that's why for now it's this, and then later we can do this. But this is an engine that handles on the file system level. And here we're in storage. And what you see here is whenever we have a list of files, we group them by store and then proxy to individual stores. And then the individual store implementations are from the default engine, the implementations. But we already do this so that we're able to handle shallow clones or whatever. You can distribute your files across whatever URLs, and as long as we find a store for it, we can read it. So yeah. This is one thing. Another thing, and this is maybe more interesting, is the new table provider. So the idea is that we need to implement all our scans go through the table provider, and right now we have many different flavors of table providers. We implement table provider also for delta table, which is the one I don't like the most. Why do I not like the implementation for delta table, for table provider for delta table? Let me just show you.
But it goes through the delta table builder, right? Or like the builder.
Here, this thing, right? So here we implement table provider for delta table, and we have unwrap in this place, which I don't feel like we should be having any unwraps at the schema. And it's exactly the reason why delta table cannot be a table provider, because we may not know the schema, because that thing isn't guaranteed to have loaded anything. That being said, the new table provider we implement for our snapshots, and what we do, and there is, well, it's fairly straightforward. So first of all, we already have this other scan, which is kind of our own scan, but it's just a fairly thin wrapper around the kernel scan. It just exposes stuff as streams, like here the metadata stream and stuff, and handles kind of the spawn blocking blah 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 thingies. And this is why we wrap wrap the kernel scan, right? So that we can already consume more idiomatic APIs, and then hopefully we'll eventually get async kernel APIs that then hopefully look somewhat like that. But yeah, it's kind of the same as the kernel APIs, just with streams rather than iterators. So now that you know this is what we do. And here, this is the interesting, or one interesting one. So we have our scan file stream, and in the poll next, we get all the files. We extract. Well, no, here we build this new stream that actually produces all the deletion vectors we need for us, and we start spawning that here. But this is another thing, because this thing right here is also like a blocking thing. It does I/O, but again, at this like async sync bridge thingy. So we produce this DV stream thing. Yeah, where we load all the stuff. This is what you mentioned earlier, right? So here we go kind of back and forth in parsing the stats as we receive them. Here we immediately extract the file statistics, and this is something that's also fundamentally changing, because our current implementations of the table provider does something, which is this thing right here. It exposes statistics. However, we cannot know the statistics unless we did a full log replay, right? And unless we did that, we don't have statistics. But we want to move to a more lazy model, right? So I was wondering, I mean, knowing Andrew Lamb, it can't be that he's like, yeah, we'll read Parquet files, but we don't expose statistics for this stuff. And it's, I mean, you have the same problem in a listing table, right? So how is it done there? And as it turns out, these statistics may be used somewhere or not, I don't know. But the execution plan also exposes statistics, and those are kind of the more interesting ones. And the listing table implementation in DataFusion, Okay. You know, I'm again asking too much of this thing. Damn it.
Is this Visual Studio Code?
No, it's Z, and actually Z is quick, but if you load the DataFusion project, kind of the
Oh well, there's your problem.
A Rust analyzer needs a little time before it can actually do something. So yeah, so this is the table provider implementation for listing table, right? And if you look closely at it, which we'll do now, you'll see they don't expose statistics on this thing, right? And Delta kind of falls into the same logic. They don't have the table statistics implemented, so they use the default implementation on table provider, which returns none. And ultimately, we are now doing the same thing, right? So this is the existing table provider, but we're just not going to implement it on a table provider, but rather, and this is what we're preparing here during the scan. Here, we extract the file statistics as we do kind of the scan, which happens in the table provider, and then the execution plan exposes statistics, kind of versus the table provider. And apparently that's enough. That's how you get all the optimization goodness. So I don't know what the ones on the table provider are used for, but the ones on the execution plan are apparently more interesting. Yeah, so we do all of this processing on the stream. So this is the stream we're getting back, right? So the scan metadata, which includes all of this. These transforms, all of y'all are familiar with kind of what the kernel APIs are doing these days. In a sense of
Sure.
when you build a scan, what you're getting is this list of files with an associated expression that you should apply to all the data you read from that file. Within that expressions, we do the renaming of column mapping, we impute partition values, yada, yada, yada. Kind of all of the Delta features are in that thing, and you get a selection vector. And this is what we extract here. We extract the file transforms as a map of strings, and then an expression. We extract the deletion vectors. We actually load them, right? So on this stream here, we this is we built this stream of deletion vectors. Build this, do some metric stuff. We actually discussed this in the last kernel sync, but we're going to lose some metrics. The count file skipped. We can't get an accurate measurement of this anymore because the price we would have to pay is to read a lot more data than necessary, or potentially read a lot more data than necessary, because this would require us to.
I'm confused.
Like
how does skipping files force you to read more data? If you're skipping them,
Well, no, on the log replay. So what you can do is you can just potentially omit files, especially in the V2 checkpoints, where you have like those dedicated files for the add actions. You may just skip the entire file based on parquet footer skipping. So never actually kind of load that data, and well, then you would have to do extra magic to see how many rows are in that file, but you may just disregard an entire file of add actions. Yeah, that's why. Here, this is where we add the statistics to the individual partition files, and this is how because then actually the work of aggregating all of this stuff into table statistics is again done by the DataFusion Parquet plan, and not by us. Here we do our thing again. With thing, I mean we order the files by object store, and then we produce a dedicated Parquet plan per object store. And then later, well, actually within this get read plan function, which is somewhere down here. No. Here. So here we build actually the individual plans, and then if we have multiple ones, then we well, union them. Okay, excellent. But the interesting part, and this is where I actually wanted to talk about, starts to begin now. Which is, how do we deal with various things? Or rather, how do I show you this? No, wrong scan. This is the right scan. No, it is not. Here. No. Kernel scan. Where's our kernel scan method? Here it is. Okay, now I know what the problem is. I'm like this. I don't know this code. No, just kidding. What? Okay, that makes sense. Let's restore that. I was just wondering, some of the most important things were actually gone, which is exactly this, which is the thing I wanted to talk about. So when DataFusion asks us to do a scan, it gives us a projection and it gives us filters, right? Expressions we should filter by. And we need to do like a little magic here, because we also tell DataFusion whether we can exactly evaluate a predicate, or whether we can inexactly process it, or whether we can't process it. So there's three cases. If we say we have exact support for a predicate, then the respective columns may not be part of the projection. And this is exactly the case when we say, okay, we support this predicate, and I can show you a test where this shows up. Okay, we have some more merge conflicts, but let's worry about this later. Which one is head and which one is origin? Oh,
I think origin is the one you needed.
I'll just delete it away.
That looks right. Yeah, I'm sure it's fine.
Okay, now, okay, there's more. We'll just use both of them, and okay, let's see. Somewhere here, yeah, those are fun too, but this test is a good example of what I'm talking about. So here we have a field in our where predicate, right? It says where date greater, blah, blah, blah.
Mm-hmm.
In this case, this is a partition column. For partition columns, we tell DataFusion, yes, we can exactly evaluate this. You don't need to worry about this. So what happens in that case is you get an empty projection because it says, I don't actually care about any column in this table, but we need to include this when we build the kernel scan, because otherwise kernel tells us, well, you can't evaluate a predicate over something you're not reading, which is something I actually wanted to talk to Ryan about, because we could apply the same logic on the kernel level and says, okay, you don't need to actually read the field if we can evaluate this only on metadata, which is the case for partition columns. But there is this kind of two different schemas we need to deal with, which is kind of what I'm doing right now, trying to work around this. But yeah, if that makes any sense.
So how did you solve that now?
Well, that's kind of what I'm working on right now. And so I was thinking, and I don't know if that'll give us what we want. Actually, while we're in that file, let me see where is this? Does this have an error? What are all the errors?
So you get a DataFusion filter, and then you convert that DataFusion filter to a kernel expression, and then push it to scan the metadata.
Yes.
Okay.
Okay, no, we don't want this back. This head. Yeah, I think that was right. Ah, okay, yeah, this is what I changed. Sorry about that. I'm just trying to, I unstashed my changes, and now. Yeah, again, I need to apologize because I'm not as quick as Tyler is in actually using my computer, but I don't see any conflicts anymore.
This makes perfect, Robert.
Oh yeah, here we need this one. Almost there. Almost there. Okay, I think now we're good. Beautiful. All right, getting back to where we were. Yeah, okay. now I was just looking for where all these errors all of a sudden come from. What I'm trying to decide what's kind of the best way how we can not waste anybody's time, because I was talking a little bit about this kernel scan, but I mean the important part is we need to extend the projection a little bit, but when we do the actual scan, we again need to do the empty projection, because when we have exact filters, essentially DataFusion doesn't then project away afterwards. But yeah, I can just deal with that. Nah. You tell me, is this interesting enough that I should go more through this? Because otherwise I just need to fix it and then put comments on the PR. There are some interesting optimizations that we can do later on, like metadata only count is actually fairly straightforward. I realized as a result of this, because when you see an empty projection, that's essentially when you can say all you care about is number of rows, and just give back empty empty record batches with the right number of rows without ever touching Parquet, which is essentially what this count optimization does, right? And it just translates to an empty projection. But yeah, we can short circuit after this. Anyway, I mean, we can't run the test right now, but I'm hoping to get this into 0.30. I don't know if that's too ambitious, but
I mean, this is all under the, what is it, snapshot next? Or like it lives in its own area, right?
It is under snapshot next. But I actually want to start making that useful. So the PR that I have open, I'll clean that up to a point. So I have a PR open on this. I'll clean that PR up to a point where it doesn't touch anything else. So maybe we can merge it after some review, but then adding new tests and integrating this into more and more operations needs to sort of go hand in hand. And I have a bunch of this here, so I'm essentially going through all the tests and getting them to pass. Okay.
I mean,
Yeah.
From my perspective, pulling in optional code into 0.30 is not a big deal. Like I have no concerns with that. I think wiring more things up to pass through it is a bigger chunk of work than I feel like you are appreciating right now.
What? Sorry?
Wiring new code paths to go through that code, or existing code paths, excuse me, to go through the new code that you're adding, I think is going to be a non-trivial exercise. Yes. So pull in the optional code, have fun. Let's pull that into 0.30. But like, I wouldn't want to hold up 0.30 to rewire everything that's going to sit on top of that. Because I think it's actually going to take, based on how painful that URL stuff was, I think you're going to find a lot of...
I mean, yes and no, because I mean, one thing I mentioned, so we're actually right now only exposing a type erased version of table provider, so nobody should ever rely on this stuff. Where it gets interesting is the optimization code and the merge implementation. Yeah, those are going to be fun. Well, I guess it's fine. I mean, I'll aim for merging that in, and then we'll see how quickly or not quickly we can actually start to use it. But the reason I'm very eager is I'm just getting tired of column mapping and deletion vectors not being supported, and especially now that we have all of this URL stuff, it feels like we're getting close to actually removing some of the biggest chunks of tech debt.
Do the tests pass for column mapping and deletion vectors as is now?
Well, a lot of tests pass. Most of the tests pass.
But do all of them pass?
No, this is what I'm working on. Kind of the thing I was talking about was the count optimization and stuff, and the different. We need a different schema for the scan to do the filtering, blah blah blah. This is kind of where I landed, but everything before that passes. So the integration DataFusion. The thing that's going to be more painful is.
See, Steve, I told you mid-afternoon he gets tired.
I haven't had my nap yet. Yeah.
The brain fog starts to set in. I get it.
Yeah.
So can you see the schema that's being passed when it's requested? And so if you do select count star you don't get a projection, so just naively assume you want the whole schema, or do you just
No, you get an empty projection. So it tells you I want nothing from you. But you get predicates that contain columns. And this is why you need to do, like, on the kernel scan, we need to include this column. And then on the DataFusion scan, we need to drop it again. But this is not rocket science, right? We can. It's just more hacky stuff than I was hoping for. But yeah, I think for reviewing, it's interesting to know. It's important to know that these statistics on table provider apparently aren't all that interesting. The statistics on the execution plan are interesting, and we're giving you those, but we're dropping the statistics on the table provider. And the exciting thing about this is there is a lot of code. I'll share again and find it.
Can I have a wild suggestion?
Yes.
What if we just wire up that table provider in Python for now?
Yeah, and let them let them deal with it.
Exactly. Because a lot of Python users have been asking for deletion vector column mapping.
Yeah, we're like, here, you wanted this.
In this state, I will flash out the bugs later.
Why isn't why is sharing not working? No, you're not. But I think, yeah. So no, you're not. Why? Okay. Now I shared again.
Yeah.
Yeah, let me get it. I'll try to get it to a state today where we can merge that in kind of isolated, not wired up yet, and then I encourage everybody to play with it, and I'll try to wire something up. But dropping the statistics, this is what I wanted to show really quick, because this is code that I found so annoying. I think it's here. No, it's not. Yes. Essentially, so this is 400 lines of code, 450 lines of code, this DataFusion module. And it's basically just trying to aggregate statistics based on the log data. And all of this can go away because we don't need to expose the statistics on the table provider. Yeah, that's why I told you. And the alternative is we record the file statistics during log replay, and then let DataFusion figure it out how to combine those into table statistics via the Parquet execution plan, which already knows how to do this. I just wanted people to know that we're, well, actually, I mean, there is some more complexity because pushing down predicates now also means we need to translate predicates from logical to physical as we push them down. But yeah, it's a defined.
You mean kernel requires physical, or?
In the Delta protocol, stats are collected on the physical columns, not on the logical columns. So when you write stats, right, Tyler, and correct me if I'm wrong, but when you write stats for partition values and for regular fields, you write stats in the physical name and not in the logical name. So
I believe so.
It's like column mapping, right? So it's just a number or an ID.
Exactly. And these are also the right statistics we need to attach to the files, right? Because they're the physical stats.
Yeah.
But then obviously kind of the query in DataFusion is expressed in logical terms.
Yeah. But,
Yeah,
but,
so we need to translate those when we push them down.
but why should we translate that and not kernel?
Kernel doesn't know anything about DataFusion.
No,
So we translate. So what? No. Okay. There's two pieces of this. The one piece is when we build the scan and we build the kernel scan. There, actually, we translate the DataFusion predicate into a kernel predicate,
Mhm.
and then we translate, and then kernel handles this. But there is more stuff on the physical side. This is like gather files for blah blah blah, and sometimes kernel then writes, not kernel, DataFusion writes new predicates as it plans. I don't know, merges and what have you. And there we need to do then some manual work. Let me find some others.
Robert.
Sorry?
I'm a bit lost.
Yeah. I'll find the actual invocations and then I'll tell you. Okay, this is an interesting function. Supports filter pushdown. Get logical plan, get table. Oh no, we're not on the table provider, but on the execution plan. So first of all, here, this is the statistics, right? And here, this is a little bit, this is our input plan. Input is the Parquet execution plan that now has the statistics, right? Because we attach them to the individual files. But these statistics, we can probably fairly easily use because they're only positional, ordinal. So we just need to make sure we get the ordinals right with partition columns that are there. So this is why I disabled them for now here. But there is this function, gather filters for pushdown. And this gather filters for pushdown, feel free to read through it. It's one of the simpler parts of the internal planning of DataFusion.
I feel like that's sarcasm.
Well,
I'm not sure.
well, maybe. Who knows? But this is some magic where DataFusion does more predicates during hash planning as it, I don't know, executes, what have you. And in these places, we do need to do translation to translate it into something that actually, actually works. Well, it works against the physical predicate because those predicates, outside DataFusion thinks all of this is logical. We wrap the Parquet plan, and only we know that there is this physical world. For DataFusion, everything looks nice and rosy, always.
But this can be implemented later, right?
Yeah, I'm trying to get kind of the thing working ASAP, and then yes, adding more and more stuff in an issue that we can later on optimize.
Yeah.
Yeah. I'm currently thinking, but no, I actually just want to get. Oh well, I mean, one thing that's fun to discuss, I think. Now live, in case anybody ever watches this. I hope
Nah,
not.
who cares? It's rhetorical. It's for our benefit.
Yes.
Carly is learning a lot. But other than that, I don't know.
Carly's here. We talked about this a while ago, and
Oh, yeah, these things.
this is. I mean, obviously, this isn't going to be part of this PR. Absolutely not. But this is how we could maybe build the APIs for Delta table. Update them, get rid of delta ops, and get the delta table in, right?
I'm
And
all for it.
this should be fairly easy to just do it in 0.30. I mean, deprecate delta ops and add those APIs. But yeah, you see, it's pretty straightforward. And luckily, all of those builders handle then initialization of the snapshot as you kind of build the operation. Yeah, but the question is, and this is, I mean, I think we have those builders here, but what could they later on return is maybe one question that's interesting. But yeah, let's not.
You mean like a merge builder, doesn't it return like a state and metrics, for example, and not a delta table instance?
Yeah, but the question is, should we just give you a new delta table, right?
But then you still need to access the metrics.
Yeah, we need to. Metrics is an interesting question.
At least from the Python side, we do it.
I mean, Tyler said something very interesting, and I think you feel that here, right? How does DataFusion expose metrics? DataFusion doesn't actually expose metrics, it just collects metrics, and then you can use those visitors after you've kind of exhausted or consumed your execution plans, right? You can use those visitors and probe the metrics that are now set on that thing after execution.
Yeah.
Right. So it's not actually part of any results or anything that we give back. And Tyler, one thing you said in the kernel discussions actually makes a lot of sense, because metrics, having them sort of part of your public stable APIs can be really annoying, because you want to exchange them, you want to, I don't know, extend them, yada, 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 yada. And having this churn in the APIs also isn't a good thing. So,
yeah.
I mean, what kernel is doing, and we could adopt something similar, is you pass in a callback. If you're curious about metrics, then this callback gets kind of called. I mean, they have this reporter, but whatever, right? You essentially, at the end, you invoke something with the metrics of that operation. If people want to pass in or want to give you this callback as they build the operation, right? And just kind of, okay, just tell me the metrics afterwards, but get them out of the results, if that makes any sense, what I'm saying right now.
No, I understand what you're trying to say. I'm just trying to think from the Python perspective, whether,
I mean, in Python we could still leave it as such, right? We
yeah,
could just say,
exactly.
okay, yeah.
I'm thinking whether that makes sense to, because it seems to be complicating things for Python users if they need to start using callbacks.
Yeah, that's.
Is there?
But how?
Are there patterns, Ian, for using open telemetry collectors or things like that in Python?
Yeah, it's quite common to do that, and I think Florian, he wired a couple of things up to do a lot of.
Yeah, we've got some things at the Rust layer.
Well, he also exposed it. Yeah, well, he exposed it also from Python, so you can initialize the tracing there. I'm not sure if the final metrics that we're getting at the end of the operation are also sent with OpenTelemetry to a collector, because that kind of solves the problem. But then the other thing is people have to start using OpenTelemetry to do maybe things they actually want to access from within Python.
Can you give me a good example of why someone would want to, like, for what use are the metrics informations at the Python level?
I have to check. I think maybe like optimize maybe the amount of files that were skipped. I don't know. I can't really recollect at the moment which things we return from the metrics.
The reason I ask is,
Yeah.
I think there's a lot of cases that we've supported where we're basically seeing, people using this information to do what are basically kind of engine type operations that may or may not be something we want to support. Like they would not be things that I would say like are should be our public APIs.
Mm-hmm.
So with my JSON change, Robert, allocations for loading a very large table went from 2 million to 1.6 million. So it cut 400,000 allocations off. That's exciting. And then
Good start.
The total memory consumption, there's like a peak. So it's hard to describe without can I share my screen? Am I allowed?
Yes.
Let's see. Because this is exciting. I'm excited. Okay, so this is Delta kernel 0.18.2 with Delta RS with a very, very large table. The one I used for load testing a transaction log. So 2 million allocations. This is with the JSON parsing changes. So that's the y-axis changed a little bit. So it's 1.6. There's also a pretty dramatic difference in that we kind of get up to 1.6 pretty early. I don't think the overall runtime has changed too much, maybe like a second or two. But then this is on kernel. So the released kernel, all of this yellow, this is basically like temporary bullshit. This is memory we shouldn't ever be allocating. And then this is with
deallocated, or
yeah. So the orange is basically, we see like this is kind of what we expect to see, for better or worse. This is the loading of the log basically. So this never really goes away. The yellow is a bunch of churn, like temporary objects that we get rid of. And then with my changes, the ultimate
that does look much nicer.
Like
I mean,
the
we
amount
end
of
up in the
memory
same
that
place,
we
but
the
path,
the max
the
is
journey
lower.
is the goal, right? What we look, what we want to minimize the peak orange and the integral over yellow.
Yes, Robert.
In simple terms.
The memory that's consumed or required for this table to be loaded in the currently released is about 3.3 gigabytes. It's about 3.1 gigabytes needed with the JSON parsing changes.
So this is without parsing the stats from the JSON.
This is not that change actually. This is, let me So this is just fixing parse JSON impl.
Okay.
To use the arrow JSON reader correctly.
Okay. Yeah.
Because before we would create a reader for every line, and then we would load every line.
Right. So now you have a larger buffer.
Much larger buffer. And instead of going through each line of JSON in the string array and parsing each of them independently, we use the decoder to properly loop through and grab our record batches.
Okay.
And finally have the test passing figured out what was missing. I got to use a new arrow function, which I'm excited about. Interleave record batch, which is fun.
What does
I haven't
do?
used that one.
Like it concatenates batches, or?
So if you have two sets of record batches and you need to have the rows from those record batches interwoven, you basically give it this. This is like an array of tuples, or a vec of tuples, and it'll say take this, this row from this record batch, this row from that record batch, and then you kind of zipper merge them together.
Right. Okay.
And so using that, we can interleave the null rows into the result.
Yeah. Okay.
Which is exciting. But it's taken me a long time to get to my performance testing of it, but like this change to this, that's really exciting.
I mean, I feel like also, and this is still far off, but I think it's awesome that we're looking into this. Well, you're looking into this, and I can sometimes ask you to run this again.
Let me show you why this matters.
Once we kind of go fully streaming via kernel and try to process as much on the stream and as batches as possible, we should get the peak load down as well, right? So ultimately we can discard a bunch of the data that we hold on to now, especially if you're in those constrained environments, and it's going to be interesting to see what they look like.
So that 3 GB of memory, that's the whole Delta table state, including all add actions, record batches, protocol stuff, yada yada.
So let's say I have 1 billion. Am I doing this right? No, it's 1,000. 1 billion requests per month on Lambda. Each one, let's say the time isn't going to change much there. The number to care about. This is not an actual number that this is just for demonstration purposes. This is $4 million a month, right?
This is your personal project, right? Yeah.
Here, let's make this 100 million invocations. So we'll bring it down to, or this in Lambda, just with 4 GB of memory, costs $500,000. Again, not a realistic example, but let's do 3192. So we can kind of cut a gigabyte of memory off. It cuts
100,000.
Cuts 100,000 off. And so for me, a lot of the workloads that I'm responsible for are Delta in Lambda. And so every megabyte matters. So let's go back up. Let's say we're memory heavy. So we'll go back to 4 gigs of memory. But let's say I can cut, we can cut the duration down.
A request duration.
The request duration, if we cut that down 1/3, then it also has a pretty substantial impact on the cost.
And I mean, as in Rust, we should take pride on being the fastest, least memory hungry, whatever, out of all of them.
We should. But one of the things that gets exciting for me and why the performance is so important is there's a lot of the workloads I'm responsible for are running in AWS Lambda. But with AWS Lambda, you have 2 direct levers on how fast it is and how much memory it is to the cost of it. And so if you push those down, if you cut half the runtime, you cut the cost of the thing in half, which is exciting.
So let's assume you're using the table provider that I'm implementing now.
Mhm.
So we already established elsewhere that the stats are probably kind of the thing that consume most memory. Do you know how much, like what are you doing in the query? So is there any file skipping
That's
involved?
literally just open table.
Okay.
But already
I mean,
parsed.
we can get open table down to very little, yeah, because we won't be holding on to the log. When you execute a query, I think so. The thing I was thinking about is we already established the stats are going to be kind of the thing that hurts us most, and we're not duplicating stats, but we're translating the stats into the DataFusion equivalent. So from that point on, the stats still exist in memory. There's a bunch of fields we're dropping, like kind of a lot of this row ID, offset, blah 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 blah. Some of the metadata field on add actions that we're not holding in onto if you just go via the lazy table or the non-eager snapshot right through the scan, right? So we're dropping a bunch of files, but the stats still are in memory. And if you're not skipping files,
If you don't need the
in your-
stats, it's all wasted.
I mean, this is something we can configure on the table provider, right? Say omit stats collection. That's why we have a table provider builder that returns something opaque, so we can shove stuff like that in without breaking APIs.
But the thing is, if you're not querying the table, if you're writing, you don't need any of it. Like, there's no point to even use to have that DataFusion level of indirection. Like this, I think this is where Abi and I have been like converging on the same point, which is for high throughput write operations, we just need protocol and metadata and nothing else. And there's a lot of machinery that we have on the DataFusion side, but also not on the DataFusion side, that are like load the table state to an even footing for every sort of use case. And for the right use case,
yeah, but this is what we're not doing anymore, right? The table provider is sorry. No, the new table provider sits on top of snapshot that doesn't load any log state. It just actions, and then when you execute a scan, then it loads it.
Yeah, but that's what I'm trying to say, is that the scan isn't like, the need for the scan is not consistent. So if you don't,
then don't invoke it.
Well, yes, don't invoke it. Easier said than done.
I mean, but literally, right? So the table provider maps to snapshot, right? And that has a schema that has protocol metadata, yada 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 yada. On table provider, you would invoke insert into, at which point you haven't loaded anything other than the original snapshot. Only if you invoke scan and want to actually read the data, then that's when we do log replay.
Carly, if you feel like it, you can bring that comment up and let Robert talk to it. That's Robert's question.
Well, yes, this is so the table provider we're working on is this, and I want to land a version in the next release of the table provider that does this, integrating with all the so wiring this through all the operations is kind of unscoped and could be a bit of work. While Tyler was off screen, Eon suggested let's just wire it up in Python.
I think it's a good idea to try.
And that would at least open up the feature to a lot of people who really want it. And yeah, it would still be that it's probably mostly supported for a scan at that point, right? If you want to do the merge, if you want to do stuff like this, this might then take a little longer to propagate through, because we need to update all of these operations. But some of them are easy, some of them are harder.
The without files concept then kind of doesn't.
Yeah, that we don't need that
disappears, right?
anymore. Well, we won't need that anymore at the point. So we still have the issue that this costs us performance, right? It costs us something when we're not eagerly loading things, because we do need some of the log replay in multiple places. When we do the protocoler metadata query, we do a partial replay at the very least, right?
Yeah.
However, now we're selective. So if we're hitting a checkpoint, we're only reading those actions. So at that point, it's actually pretty selective, and we're not reading more bytes than we have to. However, for the JSON data, we cannot be selective, right? We cannot push down predicates into a JSON read. So that's why we're reading the entire JSON log commits. And let's say the base case is, because schemas and metadata protocols hopefully don't change as frequently as your checkpointed table, that we read all the commits, all the JSON commits after the last checkpoints multiple times. Once when we do the protocoler metadata query, and then again when we do the scan. And this is where caching hopefully can help us a bit, rather than materializing it to offset that cost. We still need to do JSON parsing multiple times. But yeah.
If you do blind appends or append only, or you have an append only tables, should the caching be disabled?
You should ideally never hit it. I mean,
the cache
that's why I like.
It's on the object store integration, right? So we read JSON files.
And that's right.
And within that integration, we say, okay, we cache up to X amount of megabytes. So should we then override the object store initialization to disable?
Well, actually, I moved a little bit on this.
Okay.
Which is, I think now we looked at the file format abstraction earlier, right? Where we do the routing between different object stores, or actually different file format engines. And the good thing is, for log replay, we always go through the engine abstraction, right? So what I thought about is, let's do like a delta log aware cache on the engine abstraction, or the file format abstraction of kernel engine, because we actually ever only use that when we are reading the log. We're actually never using this when we read the data path. This is where we use our own object stores and stuff like this. And so we can have this kind of delta aware smart log, smart cache kind of, where we could also go as far as caching. At some point, we can just cache record batches. And we have this nice hybrid cache. Maybe Tyler, how expensive is disk space in like on disk cache in a Lambda? Does it also hurt?
No, there's not really a cost implication to that. The biggest challenge is with caching in that way with Lambda, and this is again, this is why I'm very skeptical of caching as a useful approach. Is your cache hit rate goes down quite a bit if you're relying on, like, it's very difficult to have a suitable cache hit rate because the environment may go away at any time. And so you might have multiple concurrent running Lambdas, and you would have, like I've done some experimentation with using disk cache for other projects in Lambda. And if you only get to reuse the cache once, is it worth it?
Yeah,
maybe not.
But I mean, this is why ultimately I think caching always needs to be completely optional, right? Configurable. Should be able to turn it off entirely.
I think the big, I mean, but pushing predicates and pushing file scan or file skipping as low as possible is kind of the
Yes.
the big deal to me. Like the fastest way to make things work is just to not read data.
This is exactly right. And especially in the case of a well-maintained table, none of this hurts us actually too bad. This hurts us in cases where a table...
Let me know when you find one.
Yeah, agreed.
That's tricky.
Let's get it to work first. I think that's the most important part. People are paying this price right now, also. So yeah. And I think even if we make that optimization, AWS is not going to go bankrupt because they're no longer making money on S3.
So regarding caching, like, do you want to disable it by default for everyone, or can you enable caching with low values of like with good defaults? Is that possible? Because there are varying sizes of disk sizes. Or do you need to assume or look up the disk size that's available and then assume a safe percentage for a table?
That's a good question. So I think there is... It's been a while since I worked with the... What was that hybrid caching crate that we're using again?
Foyer?
Yes.
Yeah.
I think they have good facilities for this, figuring this kind of stuff out. And actually, for many tables out there, if you're very like, okay, I give you 126 megabytes in memory and 512 megabytes on disk cache, stuff that you can kind of in home environments almost always kind of squeeze in there.
Mm-hmm.
But I feel like a lot of tables already fit in that. For the folks who don't think about this stuff explicitly. So one thing we could do is we could use kind of very reasonable defaults for Python, and then see what defaults we want to use on Rust, whether we say on Rust it's disabled by default and you just have that option on the table builder, or I don't know. That becomes a kind of piece of documentation. But for Python, I think we should have an opinion. Yeah, sorry, Jan.
Yeah, I'd agree.
Yeah, I was just saying the documentation which not everyone reads, because we're getting a lot of the same questions about Python stuff over and over.
Yes, that might be
hard to avoid that one.
Yeah.
Yeah, I can't really complain about it because...
I mean, I also don't read documentation.
That's what I was gonna say. I mean, when I get frustrated enough and stuff doesn't work with random trial and error, then I do actually sometimes read the documentation. But especially in Rust, since you can just kind of jump to the definition of everything you're using. Yeah, other crates sometimes put doc strings in their code, and that's helpful already. But we're down to 54 warnings on my
oh, nice.
On my local branch.
Nice. I've been thinking about this as a further optimization for some functionality. We have talked about Rayon before, but we don't have a dependency on Rayon. I've been debating whether to pull in Rayon and start to sprinkle it throughout some of core.
Well, but don't tell Andrew about this.
Don't tell Andrew Lamb?
Yes, like,
why do you want to use Rayon, or where do you want to use it?
There's a lot of things that are single core dependent that don't need to be. There's a lot of, like, if I think about log replay as an example where we do that JSON deserialization or like loading of actions or parsing of stats, there's no reason why, like we have a lot of places where there's a try collect, and like just a try collect changing to sort of a parallel version of that would more efficiently use multiple cores. Right now, there's a lot of places, especially with the kernel adoption, where we're very single core serialized. It's kind of a cheap, in my opinion, a cheap and easy way to get more parallel performance. There's just a slap Rayon on top of it.
On one hand, yes. On the other hand, also be careful. Well, careful is maybe the wrong term. But a lot of the places where we do try collect is where we collect the streams that we have on snapshots, like for the files and stuff like this. But here, I think the way to go is express that planning as a DataFusion execution plan.
That can't be the answer to everything, Robert. Just slap DataFusion on it. Can't be the answer to every performance problem.
There's no proof. DataFusion.
I've not seen proof, and your proof can't be Tyler does the performance testing, that adding more DataFusion is going to make us inherently faster.
Well, then let me step back from DataFusion. We materialize everything and then processes and discard stuff in places where we can do the processing on chunks, where we don't need to see everything at once materialized. And this is a lot of the places where we do try collect. Is because downstream we're processing on a vec and then iterating through the vec, whereas we should just do the work on the stream directly. And for those places, we shouldn't now say let's
stream's still going to be serial. That's the problem. Is that
well, like, if I mean there is concurrency now. I have to say DataFusion again. But DataFusion is not single-threaded when you execute stuff, right? And it's all streams.
It does it over partitions of the streams, right?
Yeah, I don't know where it introduces parallelism at all. I mean, you can do.
So I've looked into it before because I was looking at how DataFusion does repetitioning, especially coming from Python when it gets the record batch stream. So it tries to repetition it into multiple, or split it up, and then it does the parallel execution. So you get multiple streams that are then executed. And then later they're combined again.
Okay. Yeah, I have no feeling on. So the question is, how well can we partition, or is the table partitioned that we're using?
So part of my thinking with Rayon, Robert, is that to do what I think I want to do would be a kernel level change, not a core level change. And so the sort of like stream channel stuff that we do in kernel, I think lends itself very well, because you just give everybody the sender for that channel, and then you just blow out tasks in Rayon or equivalent to do that. I'm a little reluctant just to rely on Tokyo tasks for that, because Tokyo is not the most well suited for CPU bound optimization.
Yeah. This is the part where don't tell Andrew, because I think he'll tell you can do it all with Tokyo.
Exactly. Yeah, they're quite convinced on that.
I don't know that I've seen numbers to back that up from anybody.
Oh.
But the only comparison that you can do is that Polars is using Rayon and Tokyo, and DataFusion is doing Tokyo only. But they kind of
Polars uses Rayon. Huh.
Yeah, so they use it together.
Yeah, I think Polars. has like a complete sync core, right?
Come
It
again?
does. It does. I think it doesn't. Like in the most inner part, it doesn't necessarily even use async.
No, I mean, it should. As far as I know, it does.
I hate this so much. Sorry.
Are you fighting with your IDE again?
No, I'm not fighting with my IDE. I'm seeing if I can get kind of. I'm opening a new PR and seeing if I can get some more of those warnings down. And within test, kind of the not used warnings are meaningless because sometimes they are used.
Yeah.
Just sort of elsewhere.
Let me bounce over to Twitch. Just to reshare the link that Eon shared. And look as it pullers.
Yeah.
I mean, it's still realistically there just isn't enough time soon. But I really want to build a Polars engine, and I think Eon, you actually started that once, right?
Yeah.
But yeah,
it was for like 30% done, and then I stopped.
You can't help yourself, Robert.
Yeah, I mean, I have to be realistic. This is just not not happening anytime soon. Let's think about this once we have.
They did add extension types recently to their API, so it might be easier to now support a couple things like map types that they didn't have from the beginning.
And that was sort of an issue.
That was a problem because we needed map types, or at least to have that conversion in kernel, and they didn't have that in their Polars arrow spec.
Yeah. Okay, makes sense.
Plus, I think I was also level too low. Probably, like, you don't really want to be in Polars arrow, but probably just in Polars and handle those types. It's another discussion.
Empty string.
And there's also another thing that kind of complicates the creating a Delta engine is they've been doing a lot of work in the Rust API to support things like deletion vectors, column mapping for iceberg.
Like Polars.
Yes. So they kind of have been building.
They have their own iceberg implementation, or are they using kind of the official iceberg crate?
No, I think they actually rebuilt integration.
Interesting.
Yeah. And I think they did it because they probably were looking at also doing it for Delta eventually. So they have their own reader written in Rust with their own code base instead of relying.
I mean, this is, and maybe we can reach out there, but this is where you want to use like a kernel engine implementation, right?
Yeah.
Okay, but we have a Polars link here now. Yeah, so in core, they're not async. This is what I'm getting from this, right? They have their own pool and pool. Okay. Yeah, I mean, they obviously do a bunch of stuff with Rayon.
Like everywhere where you see pool.install, that's where they actually submit things on Rayon.
Yeah. Yeah, to be honest, I don't know enough about all of this stuff to say we should or shouldn't be using Rayon. I mean, obviously, you can get a lot of performance out of DataFusion because it's certainly competitive in query performance. But then again, also async certainly has a price, and if you're doing async obviously makes most sense for I/O stuff that you're kind of parking away and not doing some heavy lifting within your task.
Mhm.
And Rayon is the opposite.
Okay.
At least the abstraction they created for the pool seems to be nice. We can maybe reuse if we want to go along this Rayon path.
I mean, we can certainly see how well it
It's-
performs. We have somebody who's always happy to run.
Uh-huh. Yeah.
Yes.
I wish I could get a better view on this flame graph in Hotshot, but it's not resizable, which is really annoying. Let's export the flame graph. Move you over. Oh, not the flame graph. I need the call graph. That's what I want.
All right, we have a new hold on. Okay, now we actually do a new PR. Beautiful PR.
Oh, yeah.
No, hopefully easy to review. I just went through all the warnings that are left, and some of them, let's say, still motivate me. But some of them we were able to get rid of, and this PR is that.
Okay.
It's also not terribly big. All right. I do believe, though, that I do have to kind of see how I can get something to eat as the day is progressing. Yeah, but I'll do my best to get a new version of
There we go. Okay.
Of the table provider provided.
All right.
Are you planning the delta ops stuff to be pushed towards the delta table also in a separate PR?
I mean, I just did this in a couple of minutes to see what it would look like.
Yeah.
If you want to do this, feel free to open a PR for it. Otherwise, I can also just create one. But if you like, okay, this is something I find interesting now.
I mean, if you have the code laying around, you can push it.
Yeah, I'm happy. I'm happy to put up a PR with that
Do that
thing in it.
Yeah.
Yeah, I will.
And then the metric stuff, maybe we should create a discussion for it.
That's a good idea. Yeah.
Okay, let's see.
I mean, I feel like, maybe we can also do the discussion in
Harley.
Slack.
Yeah.
So, Robert, this is what I'm talking about, and this is what I'm seeing. So, CPU 0. There's 8 CPUs on the machine that's running this performance profile. Only one CPU was ever used. When I look through all of the tasks, 4 tasks. 4 tasks are being used. But I don't know if this is a Tokyo problem or if this is how we are using Tokyo. But in essence, there's a lot of bouncing back and forth here between tasks. There's a lot of things that might be parallelizable. But at the end of the day, this is just an open table, and it's completely dependent on clock speed of one CPU, which I think is a problem that needs to be fixed. I don't think there's a good justification for single core CPU performance on opening a table.
No, there is not. Yeah,
So
especially the JSON
Tokyo
regressions.
runtime, Tyler?
Excuse me?
How did you create the Tokyo runtime? Did you just do runtime new?
I did nothing. I did a Delta Lake open table.
With Python?
No.
Or
this is Rust.
So because from Python we create a new runtime, and that we use a runtime :new function, and that creates a multi-threaded runtime. But
maybe Tokyo main is not multi-threaded. So let me try to make that multi-threaded. I think that's a cargo configuration, right? Yeah, full.
Full has multi-threaded, but if you do like Tokyo main brackets num workers, I don't know. I think it's num workers, but I don't remember. And flavor multi-threaded.
Yeah.
Let's do flavor.
Underscore. So multi_thread.
Knew it was going to be underscore. Just knew it was going to be not the thing that I had chose. All right. Let's see. Do we magically fix that? Pretty sure we won't. We might use multiple CPUs.
I think the default could probably is kind of like num CPUs, blah blah blah.
Where's my CPU? Did you hide it down below? It hid it down below. Okay, so this is multi-threaded, still single core dependent.
Interesting.
I mean, just to make sure, set the num workers. Well, how many V threads do you have these days? Worker threads, yeah.
Wish is my command. Is it just underscore?
I think it's worker threads, or is it num workers?
Underscore threads.
Yeah. We feel good
And
about
one
working on this quick
CPU
fix?
can give you how many V threads these days?
Usually double the cores.
So one CPU has two, yeah, then it should be multiples.
This is not how virtual threads work. You don't get double. It's not a turbo button. By just
No. I mean, it says CPU, not threads. And if the multiple threads run on one CPU, you would still see only one CPU being used. Or not.
just like a hidden slide.
I don't know, Robert. This is not my expertise.
Okay.
Yeah.
That's what I would expect. And the reason why, like, Tokyo can't do magic if you have this sort of interleaving of requests or of tasks, basically.
I mean, but one thing would be interesting. What happens when you do the setup with I/O runtime and CPU runtime?
I don't know what you're asking me to do.
Yeah, so you create a separate runtime and then you pass it into the Delta table builder to, like it's the IO. You need to set the IO runtime config. I'll look up in our code how I'm doing it in Python.
Okay. Delta core.
So Delta table builder from URL and then with IO runtime.
Leave that there. With IO runtime, he says?
Yeah. And then your IO runtime needs to be an enum that sits under the core log storage runtime. And then you need to
Oh my
either
goodness.
already provide a runtime or a config.
This is like, it's just that easy. Okay. So we give it an IO runtime, and IO runtime is this thing. And what are you wanting me to pass it?
You need to provide a Tokyo handle.
Or a runtime config.
Or a runtime config, indeed.
What the fuck are either of these things?
So if you create a new runtime, then you can take the handle and then clone it. So
Okay. Let's IO runtime default. How exciting. Okay,
that should be. Yeah, you can use it as well. Yeah. It's not a Python.
This is getting a runtime. You think giving it a default runtime?
Yeah, that's fine because it creates an IO runtime, so it already does it for you.
No method name. Okay, so I got. Delta table builder. Oh, and then there's a build, isn't it?
Yeah.
Build. Result delta table. Blah, blah. Wait, does build do the?
Maybe you need load.
Yeah, build doesn't give you an initialized table.
Ah. Okay. Let's see what we get here. I am not expecting anything to be improved by this, but I appreciate your optimism
But
Now,
it
if
does
it's-
solve the task stealing stuff.
Because this test case, part of the reason why I use this test case is there is no data. Like this is just log replay, and it's just a giant like 5 GB log or something like that. So yeah, that's what I expected. So I think the single core performance bottleneck, I think, is in kernels scan row blah blah blah.
Yeah.
Like I think that's what like. So this this table.
Just 1 second,
So-
Tyler. Could you go back to the flame graph?
Yeah.
In the left column, the source. If you expand that, what does that say there?
It doesn't. I mean,
Like Tokyo -R and then yeah.
that
Yeah.
all these runtime workers.
But
We have a lot.
Shouldn't we now see a different Tokyo runtime as well?
I have no idea. I didn't
In
add the IO
principle-
runtime code.
I did.
Well, you'll have to talk to that guy.
Yeah.
So I think the reason we're not seeing any changes there is because there are no data file changes being loaded. I think if we were loading data files, I think we would see those other Tokyo runtimes. But this is just log replay.
But
I mean, we may
And I
need
don't
to
think
look
the IO
into
runtime touches that.
wait,
if we pass. Yeah, I don't know. Are we sure that we're passing the IO runtime? Also, that we're using the right runtime when we're building the data, the kernel engine?
it should be passed, like the IO runtime should be passed through the object store initialization. So
Oh, okay. Well, then it should.
because
Yes.
we have this abstraction in object store now where you have this request spawn thing that just uses a different handle, and we're passing it all the way through to object store.
Okay, we're building the object stores. So yeah.
Oh, Robert's walked too far from his computer.
Yeah.
Damn it. Yeah. Yeah, I do need to. See that I get something to eat though.
So why don't we call it for the day?
Yeah.
I've got some more hacking. I've got some other chores I need to do as well. I mean, the URL thing, we got that done, which is fantastic. I'm going to spin up another pull request on kernel for this JSON thing that I've been working on, Robert, and I'll pass you the
Awesome.
link in Slack when I have that.
yeah, I'll see
Jan,
that
if you're gonna still be around, I can chat in Slack on doing some performance profiling if you would like.
Sorry.
If you want to stick around, not here, but like in Slack, we can do some performance profiling if you would like.
Well, I also actually have to.
Or
cook,
you can get
but
food.
I need to get food because it's 8:30 here, and I'm
Alright.
getting hungry.
Well, gentlemen, 7 a.m. Pacific every Tuesday. Be right back here. Jan, if you have the time, you're welcome to join us for the Delta Lake live hacking that Robert and I do.
Yeah. So the thing is, I'm usually at work then.
That's
but
strange.
Just leave work.
What?
I mean, it's clearly.
And I
The
can't.
problem
really
is you're at
call-
work. Well, then,
Yeah, the thing is, I can't call from that area. If I was at home, I could call in.
nah, I understand.
Yeah. All right.